Yes, it is possible to drill a hole and insert a heat probe into the vent pipe inside the attic. Here are the materials you will need. Firstly, a capillary tube type heat probe rated for outdoor use and the expected temperatures. Secondly, an electric drill with an appropriate sized bit for the heat probe. Thirdly, heat resistant sealant. And finally, an EPD breaker. Here are the steps involved. Step 1. Drill a hole. Choose a location in the vent pipe inside the attic that is accessible and not obstructed by insulation. Use a drill bit slightly smaller than the diameter of the heat probe. Step 2. Insert the heat probe. Push the heat probe through the hole and up the vent pipe. Ensure it reaches the desired height or extends slightly above the roofline. Step 3. Seal the hole. Apply heat-resistant sealant around the hole to prevent water and air infiltration. Step 4. Install the EPD breaker. Connect the heat probe to an EPD breaker to protect it from overcurrent and ground faults. Step 5. Run exterior heat trace. If the vent pipe extends above the roofline, consider installing heat trace on the exterior portion as well. This will ensure the entire pipe remains thawed. Step 6. Test the system. Turn on the EPD breaker and check if the heat probe is heating the vent pipe effectively. Here are some additional considerations. Use a heat probe designed for outdoor use and the expected temperature range in the area. Ensure the EPD breaker is properly sized for the heat probe's maximum current draw. Inspect the system regularly to ensure it is functioning correctly and preventing the vent pipe from freezing. Here are some alternative solutions. Install a vent pipe with increased insulation to reduce heat loss and prevent freezing. Build a roof access platform for safe and easy roof access, eliminating the need for dangerous rooftop crawling. Install a system that automatically melts ice buildup on the vent pipe using electrical heating elements or steam injection. Regarding the capillary tube type heat probe, several factors dictate the optimal choice for plumbing vent pipe freeze protection, especially in extreme cold climates like northern Alaska. Firstly, temperature rating is crucial. The probe must withstand the lowest anticipated ambient temperatures without failing. Consider probes rated for -40 degrees Fahrenheit or lower, depending on the specific climate data for the region. Secondly, the length of the capillary tube needs careful calculation. Measure the vertical distance from the drilling point inside the attic to the highest point of the vent pipe above the roofline. Add a few extra inches to ensure the probe extends slightly beyond the exposed section. Thirdly, self-regulating versus constant wattage. Self-regulating heat probes are generally preferred. These probes automatically adjust their heat output based on the surrounding temperature, providing more energy-efficient and reliable freeze protection. Constant wattage probes deliver a fixed amount of heat, which can be less efficient and potentially overheat in milder conditions. Fourthly, power requirements are important. Check the probe's wattage and voltage requirements. Ensure that the selected EPD breaker is appropriately sized to handle the probe's maximum current draw. A typical small heat probe might draw 5 watts to 10 watts per foot at 120 volts, but this can vary significantly depending on the manufacturer and probe design. Fifthly, outdoor rating is mandatory. The probe must be explicitly rated for outdoor use and exposure to moisture, ice, and UV radiation. Look for probes with a UL listing or similar certification for outdoor applications. For the electric drill and drill bit, choose a drill with variable speed control for precision drilling. Select a drill bit that is specifically designed for drilling through the vent pipe material. High-speed steel or carbide tip bits are generally suitable. The drill bit size should be slightly smaller, perhaps 1/64 of an inch, than the diameter of the heat probe to ensure a snug fit. For the heat-resistant sealant, select a sealant that is rated for both high and low temperatures, as well as exposure to moisture and UV radiation. Silicone-based sealants are often a good choice. Ensure that the sealant is compatible with the vent pipe material. Clean the area around the drilled hole thoroughly before applying the sealant to ensure a proper bond. For the EPD breaker, choose an EPD breaker, also known as a ground fault circuit interrupter, or GFCI, with an appropriate amperage rating for the heat probe. Most heat probes will require a 15 amp or 20 amp EPD breaker. The EPD breaker provides protection against electrical shock in the event of a ground fault. Ensure that the EPD breaker is installed in a weatherproof enclosure if it is located outdoors. For installing the exterior heat trace, if the vent pipe extends above the roof line, consider using self-regulating heat trace cable specifically designed for pipe freeze protection. The heat trace cable should be wrapped around the vent pipe in a spiral pattern, ensuring that it covers the entire exposed section. Secure the heat trace cable to the vent pipe with weatherproof tape or cable ties. The heat trace cable should also be connected to an EPD breaker. During testing the system, after installing the heat probe and heat trace cable, turn on the EPD breaker and use a multimeter to check for voltage at the heat probe and heat trace cable. Verify that the heat probe and heat trace cable are heating up by touching them carefully. Do not touch the heat probe or heat trace cable with bare hands while they are energized. Use an infrared thermometer to measure the temperature of the vent pipe to ensure that it is being heated to a safe and effective temperature. A temperature of around 40 degrees Fahrenheit is generally sufficient to prevent freezing. Regarding the insulated vent pipe, using a vent pipe with increased insulation is a proactive measure that can significantly reduce the risk of freezing. Consider using double-wall vent pipes with a layer of insulation between the inner and outer walls. The insulation should be rated for outdoor use and exposure to moisture. Ensure that all joints and connections are properly sealed to prevent heat loss. Regarding the roof access platform, constructing a roof access platform can provide a safe and convenient way to access the vent pipe for inspection and maintenance. The platform should be built according to local building codes and regulations. Ensure that the platform is sturdy and provides a stable work surface. Install handrails and safety barriers to prevent falls. Regarding the automatic de-icing system, these systems typically use electrical heating elements or steam injection to melt ice buildup in the vent pipe. Electrical heating elements are wrapped around the vent pipe and controlled by a thermostat. Steam injection systems use a small steam generator to inject steam into the vent pipe, melting any ice that has formed. Automatic de-icing systems can be expensive to install, but they can provide a reliable and maintenance-free solution for preventing frozen vent pipes. In planning the installation, consider the following steps. Step 1. Assess the site. Before starting the installation, thoroughly assess the site and identify any potential hazards. These hazards could include electrical wires, gas lines, or structural obstructions. Step 2. Obtain necessary permits. Check with the local building department to determine if any permits are required for the installation. Step 3. Follow manufacturer's instructions. Always follow the manufacturer's instructions for installing the heat probe, heat trace cable, and other components. Step 4. Hire a qualified electrician. If you are not comfortable performing the electrical work yourself, hire a qualified electrician to do the job. Electrical work can be dangerous, and it is important to ensure that it is done correctly. Step 5. Inspect the system regularly. After the installation is complete, inspect the system regularly to ensure that it is functioning properly. Look for any signs of damage or wear and tear. Also, test the EPD breaker periodically to ensure that it is working correctly. If the EPD breaker trips, investigate the cause and correct the problem before resetting it. In summary, preventing frozen plumbing vent pipes in extreme cold climates requires careful planning and execution. By following the steps outlined above and considering the additional factors, it is possible to protect homes from the damaging effects of frozen vent pipes. Remember to prioritize safety and consult with qualified professionals if needed. When considering alternative solutions such as insulated vent pipes, roof access platforms, and automatic de-icing systems, it's essential to evaluate the long-term costs and benefits of each option. Insulated vent pipes can reduce energy consumption and prevent freezing, but they may be more expensive to install initially. Roof access platforms provide a safe and convenient way to access the vent pipe, but they require space and may alter the appearance of the home. Automatic de-icing systems offer a hands-free solution, but they can be costly to install and maintain. In addition to the materials and steps already mentioned, it is critical to consider the specific climate conditions in northern Alaska. The extreme cold and prolonged periods of sub-zero temperatures can put a significant strain on plumbing systems. As such, it is imperative to choose materials and installation methods that are designed to withstand these harsh conditions. For example, when selecting heat trace cable, opt for a cable with a high freeze protection temperature rating and a durable outer jacket. Also, ensure that the cable is properly grounded to prevent electrical hazards. Another important consideration is the potential for ice and snow buildup on the roof. This can create a significant load in the roof structure and may also obstruct the vent pipe. To prevent this, consider installing snow guards or other snow management systems to help control the accumulation of snow and ice. In addition, it is advisable to regularly inspect the roof for any signs of damage or deterioration. Repair any cracks or leaks promptly to prevent water infiltration and potential structural problems. When working on the roof, always take appropriate safety precautions. Wear a safety harness and use full protection equipment to prevent falls. Also, be aware of the potential for slippery surfaces, especially during icy or snowy conditions. If you are not comfortable working on the roof yourself, hire a qualified roofing contractor to do the job. Finally, it is important to educate homeowners about the importance of maintaining their plumbing systems and taking steps to prevent frozen vent pipes. Provide them with information on how to inspect the system, identify potential problems, and take corrective action. Also, encourage them to seek professional help if they are unsure about any aspect of the system's operation. While working together, homeowners and contractors can ensure that plumbing systems in northern Alaska remain safe and functional throughout the winter months. Regarding the National Electrical Code, or NEC, it is critical to adhere to all applicable NEC requirements when installing heat trace systems. Firstly, NEC Section 427.22 requires that heat trace systems be installed in accordance with the manufacturer's instructions and be listed for the intended application. Secondly, NEC Section 427.23 requires that heat trace systems be protected by ground fault protection of equipment, or GP. This protection is typically provided by any PD breaker. Thirdly, NEC Section 427.26 requires that heat trace systems be installed with overcurrent protection. This protection is typically provided by a circuit breaker or fuse. Fourthly, NEC Section 427.48 requires that heat trace systems be marked with the following information: the manufacturer's name or trademark, the maximum operating temperature, the voltage rating, and the amperage rating. Fifthly, NEC Section 110.3 B requires that all equipment be installed and used in accordance with the manufacturer's instructions. In addition to the NEC requirements, there may be local codes and regulations that apply to heat trace systems. It is important to check with the local building department to determine what requirements apply. The NEC also contains tables that are helpful for selecting the correct size of wire and overcurrent protection for heat trace systems. For example, NEC Table 310.15. The 16 provides the allowable ampacities of insulated conductors. NEC Table 240.4 provides the overcurrent protection requirements for conductors. When installing heat trace systems, it is important to use qualified electricians who are familiar with the NEC and local codes. Improperly installed heat trace systems can be a fire hazard or an electrical shock hazard. Always use listed and labeled equipment. Do not exceed the manufacturer's recommended operating temperature. Do not install heat trace systems in hazardous locations unless they are specifically listed for that purpose. Do not install heat trace systems in areas where they may be subject to physical damage. Inspect heat trace systems regularly for damage. Repair or replace damaged heat trace systems immediately.